Alright guys, I thought I would just show you this new heating system in my new place. This is rather unusual. This is the boiler that you see in front of you. It's not very large, there's my hand for comparison, so it's about 5 feet long, but it's not very wide. And this, rather unusually, I've not seen one of these before, but I'm sure they existed, is an electric boiler. And to be honest, it's crap because it's nowhere near powerful enough. This is 11 kilowatts, but that's nowhere near enough for a conventional hot water and radiator heating system. Your typical gas boiler is going to be in the region of 30 kilowatts. So this thing takes ages to get heat up from cold, and but once it's up and running, it's generally okay. This place is reasonably well insulated. So it doesn't need to run continuously, it does actually reduce down. In fact, it's reasonably sophisticated because it's all solid state switched, 0 voltage switched, opto-coupled triacs and stuff, so it's all pretty neat. So there's the main isolator switch, power feed there, some pretty substantial silicone cable there, and it has separate outputs for a water pump and to the controller, which is over here, and this is a fairly standard timer controller. The actual plumbing system is a fully sealed system, so you've got your expansion tank there, and you've got a filling loop to allow filling from the cold water supply, with the legal requirement of double redundant isolator valves to prevent backflow into the drinking water supply. Pressure gauge there, which reads about 2 bars or so, so it's fully pressurised. Anyway, let's turn it on and see what happens. If I can get the phone focus, we'll turn it on. There we go. We heard it kick in. Okay, so there's quite a long delay where I presume it performs some sort of self-test, so you can see the call for heat lights flashing, which means that there is a call for heat and it's waiting to start up. And while that's doing that, we'll have a look at the specifications here. So, output 65 to 80 Celsius, 3 bars, 9 to 11 kilowatts, 220 to 240 volts. Obviously, there's a range given because this thing can produce quite a large voltage drop. Now, you'll see when this thing eventually starts up that there's an interesting little mitigation feature to causing light flicker, which is the fact that it soft starts, and there's actually several individual elements in here, and they're all individually switched, and depending on heat load and depending on, well, according to a program when starting up and switching off, you'll see that they're controlled individually. Okay, the call for heat lights come on continuously, and there we go, first element on. And second element on. So there we go. Soft start, semiconductor switched ZVS for low EMI, and flicker. So that's pretty cool. So this operates the normal radiators. We'll turn that off, we don't need it. Okay. Hot water comes from this 210 litre cylinder, and it's heated by an immersion heater at the bottom and a boost immersion heater at the top here, which are controlled by this timer control unit, which is rather overly sophisticated because this is designed for an off-peak electrical supply, which this property doesn't actually have. So you've got your master switch off and timed, and you've got a timer here which is factory set for 7 hours, and you will then adjust it to correspond to the time at which you get cheap rate electricity, and when this timer is on, it will turn on the bottom heater. There's an alternative. You've got this boost heater here, which is the top heater, and this can be turned on any time here, and that will turn on the top heater. If the event that this comes on while the bottom heater is on, this one will override, and the bottom heater will be turned off to minimise electrical load. This is just a fairly standard unvented cylinder here, so we've got a pressure regulating valve here coming from the mains water supply, which is this item here, and then there's a pressure relief valve here, an overpressure valve here set at 4.75 bars, and that's cold water feed. On the top here you've got an over temperature and overpressure valve combined. Let's see if we can see what it says on it. It says 6 bar, 90 to 95 Celsius, maximum 10 kilowatts, which is the maximum flow, which is 10 kilowatts means the maximum flow rate is sufficient to prevent heat build-up with up to 10 kilowatts of heating, and these elements are 3 kilowatt. Like all reasonably posh tanks, this has got an option for a secondary return, so you can have a secondary pump on here which pulls water through the hot water output round past your taps and returns it back to the cylinder for reheating. This way you don't have the problem of cold water in the pipes, so you turn on the tap, you've got hot water immediately there, but nobody puts it in because it's expensive. You know, you've got to pay for another pump and an extra sort of 10 feet of pipe. So and most consumers are too stupid to know about it, and most builders won't put it in because people won't understand it as a selling point. This is something I don't understand. I'm not really an expert in the legislation for these things, but you'll see that the pressure valves here drain down here through this visible ton dish, and then they're supposed to drain through a metal pipe. My understanding is that the building's regulations require a copper or metal pipe to drain the hot water in the event of a temperature or pressure valve release, because the temperature and pressure release valve here can release a real torrent if it trips on over temperature. Let's see if we can test it. And because it can be at boiling point, the risk is that the plastic may soften. But anyway, this is plastic, and they've always been plastic as far as I've ever seen. So I'm guessing that that's probably an out-of-date bit of legislation, or interpretation of the legislation. Anyway, I don't use that heating much. This thing here produces pretty much as much heat as I need for the entire house. This is my Bitcoin machine. Quite a lot of graphics cards on there. Produces around about 2 Bitcoins a month. But I've modified it from when you last saw it. I've spaced out the graphics cards a bit because they were overheating, and I've got these rather dinky things here which are PCI Express extension cables. So this connects down to the motherboard down there, goes up there, and these are basically USB cables there, and it connects down to that little PCB on the bottom of that graphics card, which is, so we've got a total of 9 cards here, 3 on each motherboard. So you've got one there connecting down to this card at the back. This one here is part of that motherboard, and then there is another set of 3 at the bottom there, which is all running fine. These have got these cards are AMD 7950 cards, and they're all running custom BIOS, which is to reduce voltage and power consumption, and the cards are a lot happier now with that custom firmware. So this whole machine uses about 2,300 watts, which is a reduction of about 200 watts with optimization. And it's now running a full complement of cards. It's actually got 9. The previous video I think I had only showed 8 because one of them had burnt out. But yeah, these I'll have a quick look at these PCI Riser cables. Okay, so I got these cables off eBay. They're about £12 each, and they're quite dinky. So essentially what it is you've got a USB 3 cable. This appears to be a fairly standard USB 3 super speed cable. You can see, as is typical of USB 3, it's got a second row of contacts at the back, so it gives, I think, 3 or 4 pairs of differential signals. This is the motherboard end of the connector, so just a tiny little PCIe single channel connector which just plugs into the slot, and it just terminates in a male A USB socket, an A female, sorry. That's it really, very simple. And then you've got the actual main board, and this will accept your graphics card, USB socket there for the signals, and the power socket here to provide bus power. So you can provide 75 watts of power to the card through the slot. This USB cable is not going to carry 75 watts at 12 amps. And you've also got here another a 3.3 volt voltage regulator and a bunch of filter capacitors for the card. Some thick neoprene insulation here, so things don't short out. It's not a bad piece of kit, and it even comes with this SATA to hard drive adapter. Lots of power supplies these days have SATA connectors rather than these AMP connectors here. So it's very easy. You just plug in the card, and that's it. And this one here, you've got to be careful to get this the right way around, otherwise you'll short things out. It goes in like this, so it hangs out the end of the front of the slot. And that's it really. The only thing is you have to be a bit careful with if you're using these for multiple power supply systems, and you need to make sure if you're using 2 power supplies, one for the cards, one for the motherboard, that they're both very, very strongly grounded and connected to each other. You need to make sure that there is good equipotential bonding between the analog ground on both power supplies. I made the mistake of connecting these risers powers to the secondary power supply, which was powering the graphics cards, and powered the motherboard from a separate power supply, and didn't put enough equipotential bonding on the two. The result is that when you turn on the switch on the secondary power supply, you get big capacitor charges, you get various inductive pulses and stuff, which can affect the ground voltage on that, and if you don't have enough equipotential bonding, you'll get coupling of that into the card and onto the signal wires, and you'll blow the PCI bus on the motherboard. So one thing to be a little bit careful of. But these are quite fun, and after separating out the cards, they run a lot cooler. And this is the other interesting thing, is if you can get the core temperature of the cards down, they actually use less power. The leakage current through the CPU core increases the temperature. Now, I didn't realise that. And just by dropping the core temperature from 85 degrees Celsius to 65 degrees Celsius, which is what they're currently running, that alone has reduced power consumption by nearly 70 watts. Even before voltage reduction. So there we go. Hope you find that interesting. It's a bit rambling, but there you go.